Hello, welcome to section 6.1 continued. We're going to be taking a look at example 4, and it states that given angle B is equal to 78 degrees, side C is equal to 12, and side B is equal to 5, we're going to find angle C. So how do we go about doing that? Well, as it turns out, you do need to identify which case this relates to start with. And as it turns out, we're going to go ahead and take a look at how 78 degrees is in fact an acute angle. And no, you're not always going to start with angle A, nor are you going to be given side A and or side B. In this case, you're actually given side C. Now, you can actually see a little bit of writing here already, which is going to be uncovered here very shortly as such. So B is less than C. Okay, obviously that's the case. 5 is less than 12. But as I continue relating what we discussed at the beginning of our notes, B is actually also less than H, H being the height of the triangle. So this in fact is going to relate back to case 4, which I'll refresh your memories on here in a moment. It turns out that there is no triangle that can be drawn with case 4. But why is that? And also, why is the H quantity something to decipher, which you can see just below this? So yes, it does show that there is no triangle again, but why? Well, the height of the triangle can be deciphered by using C times sine of B. That's just the generic setup for any time you're asked to find the height of a triangle, knowing a side and an angle, of which is not the opposite side of the given angle. B is obviously opposite angle B, but you're not going to use that in the equation as such. You're only going to use C and then angle B. So C sine B. If you do 12 sine 78, you do end up with 11.74. Now there isn't a triangle that can be drawn with this. And yes, as you can kind of maybe denote up top here, there is something to be said about using law of sines to also possibly prove this to be the case. Again though, let's refresh our memories on case 4 before I uncover anything else. Case 4, it is denoted as follows. When the side given, particularly the side that's opposite the given angle, when that is less than the height, and again I denoted that the height is B sine A generically speaking, but it could be C sine B, it could be A sine B. So if again those two are different variables, so to speak, one of which is not the opposite of the other, B is not opposite A is less than H. In other words, the side that is given as opposite the given angle is less than the height. So you cannot draw a triangle given this situation. Okay. If I continue, but using though the law of sines in context, let's see how this works. So if I were to do sine of C over side C, and notice I have sine of 78 on the other side already. Sine of angle C, which is unknown, divided by 12, set that equal to sine 78 over 5. And if you cross multiply, maybe we can attempt this. If we do the math here, of course, we'll do 12 sine 78. Make sure you're in degrees. And then if you just simply divide that by 5, let's hit enter first. And then if we divide that by 5, this is the quantity that we're going to go ahead and find the inverse sine of. Now 2.35, as we're about to see here, is the right side of the equation. But if you go ahead and try on your calculator inverse sine of that decimal, the calculator very quickly, and I would argue as easily as it can be done here, as an error. So you cannot do the inverse sine of such a quantity. Therefore, that's even more evidence that there's no solution, therefore no triangle. So mathematically, that would be a good thing to kind of finish with. So case 4, as you see, can't even draw a triangle. Okay, example 5. So this is the ambiguous case. I'll just tell you now before we get started, but really why I think is a good thing to denote as we begin. So first it shows, or it's giving you, that angle A is 29 degrees, side A is 6, and side B is 10. It says find all missing sides and angles. So if we go through the process, denoting our picture, and yes, you should attempt to draw a picture here, If you can't draw a picture like we did on the last problem, you know, you can't just jump right in like this. But here's something to consider. The reason why you can, in fact, draw a picture, unlike the last problem, is because angle A, here's my picture. Yes, there are two triangles, as you're about to see more specifically. Angle A is 29 degrees. Angle A is an acute angle. I'm going to slide this up just a bit. Okay, I'll just point to this as angle A. Okay, so angle A is acute. Side A, which is opposite angle A, is less than side B. So again, how and why is this even plausible to be drawn, but also how and why is it a two triangle or ambiguous case situation? Here's the depiction that we discussed in our prior work with section 6.1. This is the situation where here's A as acute, side A opposite angle A, side B adjacent, and therefore A, as you can see, is less than B. So in effect, yes, H, which is here, the height of the whole triangle, is less than A, which is less than B. So there are two triangles, at least by virtue of the picture. By virtue of the actual values, well, we can see that to be the case also. We still have to find the height and do other analyses as we progress. The height, speaking of which, we can calculate. The height is equal to B times the sine of A. If you recall, you can set up a separate equation such that sine of A is equal to opposite over hypotenuse. So that would be H over B. Okay, I don't have H depicted here, but H, as you hopefully recall, is the height denoted here, or what would be denoted here. So the height can be found as such. You do 10 simply, sine of 29, and you do end up with a fairly nice number, 4.85. Here's where it gets more interesting, of course. So there is another version here, as you can see, of which you can take side A and just kind of rotate it in. So side A could be actually here, not just there. So here's where the ambiguous case again kicks in. Again, H, which we just found to be 4.85, is less than A, which we know to be 6, which is less than B, which we know to be 10. So we know that two triangles will unfold here, and here's the depiction that makes sense fully, as you can see here. Now I've denoted not just AB as before, angle A, side B, angle A, side B. I've also denoted, and here's side A has different depictions, and one in blue and one in red from above, but I've also depicted with a variety of subscripts. So I use this first triangle here, denoting this as B sub 1, second triangle B sub 2, first triangle C sub 1, second triangle C sub 2. So the law of sines will be your approach essentially when it comes to solving. You do see the answers for angle C sub 1, C sub 2, and side C sub 1, but it's the law of sines that prevails here. This is how it's going to work. And yes, this is a lot of setup here, but please take a look. It actually will make nice sense once you see it all come together. The main ratio to use is sine of 29 over 6, because those are the two distinct parts of which are opposites of each other. So you're going to use that continuously. Okay, so with sine of 29 over 6 set to equal to, we have sine of 24.9 over C sub 2. I do need to denote where 24.9 came from. And I will do that if we take a look at some of the math that here I'll uncover below. So yes, you do have an angle of B sub 1, you have an angle of B sub 2, you can see the values. I should actually denote where, again, though, 24.9 obviously is coming from. Turns out you guys can use this proportion first. So I did jump to 24.9. Let's get to that in a moment. Technically, we can solve for B sub 1 first. And the way we can do that is by virtue of cross multiplication. We can also technically do the same thing for this ratio. Let's see how this is going to unfold first. So we'll go ahead and we'll do 10 sine 29. And that answer ends up being that decimal. And then we'll divide by 6. Now remember, this is not quite B sub 1 as an angle yet because we still need to do the inverse sine of that number, which turns out to be inverse sine of that decimal. There we have, hopefully, 53.9. Okay, so look at the picture. I've drawn it in a way where b sub 1 looks to be acute, while b sub 2 appears to be obtuse. And that's true in the sense of, how I labeled it and how they look. 53.9, again, because that's acute based on the math that we just did. If you look at the picture at the very beginning here, this is supplementary to b sub 2. So this angle right here, technically, that's b sub 2. Okay, if you look at this angle again, that's the same as that. These two angles are actually congruent. Why? Because this triangle is an isosceles triangle. So if legs are congruent, then opposite angles to those legs are congruent. This is an isosceles triangle. These base angles are congruent. Okay, so again, we found 53.9, which is technically this angle. So if this is 53.9, again, so is this. But also, this is 53.9. And as I already said, these two are supplements. So what we can do is we can take the difference of 180 and the angle that I just came up with, which is 126.09. I want you to keep in mind all these decimals need to be saved on your calculator, or at least something that you can easily go back to. Certain calculators allow you to do that. So for this particular question, again, there's your angle, and I show my math here to find, obviously, angle b sub 2, 126.1. And now that you know two of the three angles of this triangle, you know b sub 1 and a, you can subtract from 180 to find c sub 1 is 97.1. And because you know 126.1 on this triangle here, as well as this angle 29, add those two, subtract from 180 to find c sub 2. And lo and behold, that's the 24.9 degree angle c sub 2 that I was referencing earlier. So I did actually use this proportion first, but this proportion now in context could be solved for. When you do this on your calculator, again, it is crucially important that you use, I would argue, the decimals in full. I would not round in the middle of a problem if you can avoid it. So if I just looked at the triangle on the right, notice I'm going to go ahead and use 180 minus 126 plus 29 such that you end up with that value, as I said, 24.9. Don't round. Use that decimal. So now when you cross multiply 10, I'm doing 10 sine 24.9, setting equal that equal to c sub 2 sine of b sub 1, or actually this would be a better ratio. You could use this knowing now b sub 1, but that would require you to go back to 53.9. Instead, I'm going to cross multiply with these ratios. So let me go back a step, and I apologize, 6 sine of the second answer, don't round it again if you can avoid it, and that equals a decimal, divided by sine 29, and that, remember we're solving for c sub 2, that should be the length up to 1, which is what I've denoted right here for c sub 2. You're going to do the same thing for side c sub 1. In other words, I would cross multiply these two. Again, using 97.1 in context requires 180 minus the sum of those two. And be careful again, you use 53. If you use 53.9 as that, it's going to possibly lead to, instead of c sub 1 as 97.1, maybe you get 97 point something else, which is not what we want. Using the decimal appropriately, and then of course here when you cross multiply, you should end up, and I'll leave that math up to you, but you should end up in cross multiplication with the final value such that c sub 1, and look at the picture, c sub 1 is bigger than c sub 2. So your final answer for that particular side is 12.28. I recommend that you look through this problem as it relates to not just being given A, and B, but other parts that are similar in nature, but the letters are maybe different.